Yes, greetings of the day. Today we'll discuss about formal modeling framework for fog computing. Myself, Dr. Sheikh Haja Muhiddin, Associate Professor from CSE Honors Department. I present myself before you with the topic formal modeling framework for fog computing. So definitely whenever we go for any kind of thing, a framework is very important for that. So if we are going with a defined framework, it basically indicates that we are going with some certain sort of standard things. Okay, so in the similar way here in the edge computing we are going with the concept of the framework of the fog computing. So the important things that we come across here with respect to this framework are nothing but this framework could be represented in a hierarchy. Hierarchy means what we are having various sorts of levels. Okay, so whenever we are talking about the levels, definitely there may be higher to lower levels. So here also when we talk about modeling framework for fog computing, so this is going to be carried out in hierarchy of 3 layer models. Okay, so a higher model, middle layer and lower layer, and each and every layer is having its own sort of importance. So with respect to every layer, a particular sort of task are going to be carried out. So here when we talk about so that is nothing but a hierarchical. Okay, hierarchical. So that means in a particular order, one by one. Hierarchical means one by one. So here also the layers are being carried out one by one. So that is nothing but higher layer, middle layer and lower layer, and each and every layer is having its own sort of importance. So if we are going to view the highest layer, okay, that is the cloud with its virtually unlimited high performance and cost and energy efficient resources. So as we have discussed that every layer is having its own sort of importance. That means what every layer, whether we are talking about the highest layer, middle layer or lower layer, every layer is having its own sort of importance. So here if we observe the highest layer, that is the topmost layer, so with respect to that layer we can carry out the applications which are related to high performance, okay, cost and energy efficient resources could carry out their applications with respect to this higher layer. So that means what high performance means we want to get maximum performance with respect to any application that is running, or with respect to any device that is running with that is connected at the higher level. So at that time we can expect to get high performance, whether that is an application that is running at the highest level or whether that is a device that is connected at the higher level. So at the same time these sort of applications or high performance should be carried out with cost and energy efficient resources. That means what, in order to run the application we need certain sort of resources, and that means to execute the applications, suppose we want to run a particular applications, so that particular application to run we need certain sort of resources. So here we have to run an application in such a way that should be cost and energy efficient. So it should use less amount of energy, at the same time, that means computational energy, at the same time it should use minimum, or that means if available number of resources are very less, with respect to those resources we can carry out the application. So highest layer is meant for to carry out high performance with respect to cost and energy efficient resources. So when we come to the next layer, that is the middle layer, that consists of the edge resources. So what are they? So what kind of edge resources, or what are the things which are being carried out by such kind of edge resources? Those are nothing but machines which offer the computation services, okay, near the network edge. So example, there is a base station. Okay, so with respect to a particular base station we are having certain routers, bridges, okay, whatever may be connected. So such kind of devices could carry out their application if they are kept in the middle layer. So middle layer works for the execution, or to run the application with respect to certain sort of edge resources. Okay, so what kind of edge resources we are talking about here? So those are nothing but network edges, okay, routers, so like that. So routers, base stations, okay. So at the same time we could carry out geographically distributed data centers for telecommunication providers. So when we talk about the telecommunication, so what do we observe with respect to a telecommunication? So there is a tower at one place, and devices which are connected to that particular tower may be distributed at various places. For example, with one suppose nowadays we are communicating with cell phones. So every tower, that means every cell tower is having certain capacity to maintain certain number of cell phones. So here in order to carry out such kind of application, so with respect to one particular tower, how much devices it could maintain, or how much applications it could run with respect to those devices. So such kind of entire things we can carry out with respect to the middle layer. So next, the edge resources are all connected to the cloud. So here at the top layer we are discussing about the high performance, at the middle layer we are discussing about the resources which are being carrying out their application with respect to edge computing. So all these things are being connected to the cloud. So here when we talk about the concept of the edge, okay, that has been we can say that has been derived with respect to cloud. So when we talk about the cloud, so there are huge number of n number of resources that we can carry out their applications with respect to pay per use, like that. But when we talk about edge computing, we want the responses very quickly, okay, very quickly. That means in the sense, suppose nowadays with the advance of the technology, if we observe in the future, Google is going to plan to come up with driverless cars. So whenever we are going with such kind of things, what happens, driverless cars means they are connected to certain server. So lot of sensors are there. So the sensors has to collect the data. With respect to that collected data, immediate response has to be carried out. So to suppose a driverless car is going, and at the in front of that certain obstacle come. So what is the instant scenario that the car has to do? It has to immediately apply the brakes. So how within that span of time these actions should be carried out? So how such kind of things are being carried out? That means with with less response time. So immediately it collects the data. Depending on the data, what it has to do, so immediately within no time it has to get the reply also. That means we have to apply the brakes. So if these devices or these servers are kept in the cloud, which are very far from the scenario, so that takes a bit of time to get the response time. But if we are going to connect with the nearby servers, so that enhances, or that makes the bubble to come out with respect to the concept of the edge. Okay, so this is how we can carry out with the concept of the edge computing. So as we have discussed, so if we observe there, so at that at the hierarchy scenario we are having the cloud. After that we are having the edge resources. So every edge resource is connected to a lot of end devices. Okay, so IoT devices, so like that. Okay, so this is the scenario of the hierarchy. So whenever we talk about the fog computing, we immediately within our mind we should strike that we are going to discuss about a 3-level hierarchy model. Okay, with the cloud at one level, edge resources at one level, and end devices which are being connected, as we have discussed now. So what is that edge resource? Suppose the edge resource is nothing but a router, or nearby router to that particular car or vehicle. So what are the end devices? The sensors which are connected to the particular car. So immediately if they want to, suppose the sensors are at the end devices, okay, immediately if they want to get a reply, well, is it better to connect them to the edge resources or to the cloud? So definitely there is a connection between the cloud and the edge resources, there is no question for that. But to get an instant response, okay, so we could connect to the nearby edge resources. So that's why I think that real time example could give a much scenario to understand the concept of the edge computing. So here metrics, that is nothing but what are the dynamic things that we could carry out with respect to the edge computing. So depending on the specific optimization problem, see whenever we talk about the concept of optimization means what? To give the best, okay, whatever it may be, whether that with respect to the cost, with respect to the running of application with respect to response time. So optimal means to give the best. Okay, so here also with respect to certain metrics we could carry out to bring out the best of that one. So that is nothing but optimization. Okay, the concept to try to level up the best. Okay, for example, one problem variant may look at a real time application is that overall execution of the time needs. So as we are saying now, so whenever there are n number of IoT devices or sensor devices which are connected, so in order to carry out the response, so immediate within no time we have to get the action also. That means what could be performed with respect to this kind of action. Okay, so that is low latency should be maintained, that could be carried out with respect to the concept of the edge computing. So here there are certain metrics that we could observe. So what are they? One is the performance, resource usage, energy consumption, financial cost, further quality attributes. So performance, whenever we are talking about the performance, perhaps the edge resources which are the edge devices which are connected to the edge resources, we can talk about the performance of them. Okay, the resources usage, that means as we discussed, whenever an application is running with respect to limited number of resources, by using it should complete the task. Okay, so like that resource usage, energy consumption. So this is also one of the main factor. Energy consumption, in the sense what we are saying, energy consumption is nothing but whenever we are running an application, so the application runs with certain sort of resources. So these resources should be in the way that they should consume a bit of less energy. Okay, so the concept here is that performance should be high, there should be no compromise with the performance. Resources with limited number of resources we have to carry out the thing, and the energy that is consumed, whether we are using a bit of more resources, whether we are using a bit of available number of resources less than the required one. So energy consumption is also playing a very important role. Okay, so at the same time financial costs, what the investment that we are carrying out in order to buy the devices with respect to the edge devices or edge resources. Okay, so like that. And what are the other attributes that come under which could be considered with respect to these metrics. So that is nothing but the further quality attributes. Further what are the parameters that we could consider in order to enhance the quality. Okay, so let us go with the first one, that is nothing but the performance. Okay, so there are several performance related metrics. So how we can say that this particular device, okay, this particular IoT device or this particular edge resource is going to give as a good performance. So the concept is nothing but the execution time. Okay, so latency. Okay, latency means what? Within quick we have to get the response. Suppose we open a browser. Okay, browser, there we search for anything, we type anything in that browser with respect to Google. So what happens? We get n number of things. If you observe there, 1 lakh things are being obtained in 0.11 second. So that indicates what? Latency. Less the latency, it gives more elaboration for us. That means what? For whatever we are asking, if you are getting within a quick response, the end user also feels a bit happy. Suppose you are chit chatting with your friends, okay, or you are just on a you are connected to a bot. So whatever the question you are posting, immediately you get a response. So what happens there? The end user feels a bit that means responsiveness. The responsiveness is very good. Okay, it's we could consider later that whether the response is correct or not, but whether we are getting the response or not. Okay, so that is within no time we have to get the response. That concept is nothing but called as latency. So latency is one of the performance measurable metrics. Okay, so next throughput. Okay, output. So output is what do we expect when an application is running? We should expect a quality output. Okay, so how we can discuss the output? That depends on the kind of the application that you are running. Okay, so in certain point of application you require to get less output with quality. In certain applications the requirement is that you should get more output with that means quality does not matter. So that depends on the scenario where, okay, throughput has been satisfied or not, output. Okay, so generally performance is related to the amount of time needed to accomplish a certain task. So definitely within the stipulated time the task need to be completed. So perhaps there may be deadlines, soft deadlines and hard deadlines. If the hard deadlines are being crossed, so definitely penalties will be there, and soft deadlines, it does not matter for penalties, but if the things are being executed, definitely we could observe that we are getting good things. For example, there is a hard deadline. Suppose a airplane is landing in an airport. So by the time the pilot is switching, okay, he makes a switch such that the tires should touch the ground. So the time is very important there. Okay, even milliseconds of late for the tires to touch the ground, okay, at the where the aeroplane is landing at the airport. So that costs much. So that's why that is a hard limit. That means fixed. Okay, within this millisecond, this task should be happened. Okay, that is a hard deadline. So when we talk about the soft deadline, suppose you went to a particular ATM center. So with respect to your ATM card, you want to dispense the cash within your bank account. So there, what do we observe? You enter the card, you enter the pin. If everything goes correct, so it takes a bit of time. Okay, the machine rolls, it collects the number of notes with respect to balance your account. So at last you get the currency notes. So that means what, there also time limit is there. Okay, within 2 minutes or 3 minutes the task should be completed. But if it is not going to be completed, then also what happens? Okay, result is good, okay, but that is a soft deadline. If the result is completed beyond the time, okay, you have to get the cash should be dispensed within 2 minutes, but it is taking 2.5 minutes. So there also there is no loss. So if when we compare the hard limits and soft limits, I think with these two examples we got a correct idea. So next, the completion time of the task may depend on the computation time. So definitely if the computations, if you are going to carry out more, that means if you are going to carry out with more complex application, perhaps we have to wait a bit of time in order to get the result. So at that time the performance may be good, but it takes a bit of time. Okay, the total execution time depends on the critical path of the compute to transfer the steps. So sometimes what happens, you want to track an information. So that information you could get is at a server that is very far away from you. So we have to send a request and immediately you have to get a response. So in between, if a particular router or a particular device is busy, it takes a bit of time, okay, in order to get the response. So like that. So latency, okay, execution time. So these are the metrics with respect to the concept of performance. Okay, so next, resource usages, as we have discussed now. So resource usages means whenever you are running an application, perhaps with respect to the processor, okay, the kind of storage, okay, the kind of the device or the resource you are being connected. So that is also very important. Okay, so some depending on the application, if you are running a complex application, what do we observe? In sort of complex application, more number of resources may be the requirement. In whenever you are running a simple application, so at that time what do we observe? There might be a few resources that you require. Okay, so whatever it may be, with sufficient number of requirement of the resources, our task should be completed. Okay, so that is the resource usages. Okay, yeah, we come across certain scenarios where when we are running an application, okay, that demands for more resources, but at the run of the application the resources may not be available, but at the middle of the running of the application we could provide that. So that could be another scenario. So here edge resources typically offer high capacities. So definitely, so when we are running a complex application, what do we observe? So high capacity outputs we can observe to get, but also those capacities are can be limited in the sense what, we could fix a time bound. Okay, we could fix certain sort of efficiency that we have to get the output within the first slot or within the second slot, like that. Okay, so given that edge resources may include machines like routers, okay, that do not offer exhaustive computational capabilities. Next, to some extent CPU usage. So as we have discussed now, so inside a system, when we talk when we are running an application, so with respect to the processor, the memory that we are using, so these are the things that we have to carry out. So if you are running a complex application, definitely more computation task or more processor or high usage of the processor is required. So kind of the application that you are running, beyond that, okay, you can decide, okay, if that is a simple whether that is a simple application, whether that is a complex application, whether the kind of application require more number of resources, less number of resources. So at the same time, along with the processor, we require certain usage of the memory also. So all these things could be carried out under the concept of the resource usage. Okay, so this is also one of the important metrics. Next, energy consumption. So as we said, whenever we are running an application, okay, we require certain sort of resources. So when the resources are running, what are the basic thing that we observe? The consumption of the energy. The resources are going to consume certain sort of energy, okay, certain sort of energy to run, okay, in order to execute the application. So here our scenario is like that, we have to observe that these devices that are running, they should not consume high power, okay, that means with minimum power. So due to that, what happens, we could enhance the wastage of the power, or we could enhance the high usage of the power. Some application may require a limited power, at that time no need to consume high power. Some application require high energy to be carried out, at that time what do we observe? So the relevant amount of the energy, what is the minimum, what is the optimal thing, okay, that is required, that we have to give, rather than not more, not less. Okay, so energy consumed by all the devices as well as by the network. Okay, even idle resources and unused network elements consume energy. So here we have to observe that what are the resources which are not being used during the run of the application, which are not being connected. Okay, so such kind of things we have to identify, and we could pause them so that we could save a bit of energy, and all these things should be carried out without human intervention. Okay, so okay, these things are very important here. So next, energy consumption is important in each layer. So as we have observed, out of the 3 layers, whether that is a cloud, whether that is a edge, whether that is a edge devices, okay, edge resources, edge devices, or end devices. So at every level, okay, depending on the level, when we talk about the cloud, there are huge number of servers. Okay, when we talk about a cloud data center, inside a data center, what happens, there may be thousands of huge servers which are running. So not all the servers required to run, because if they are not being used, what happens, they still consume the energy. For example, consider a cloud data center that is having 100 huge servers. So only 10 servers are being used. In the 10 servers are being used in what manner? One server is being used 60%, another server 30%, another server 20%. At that time, what do we observe? We have to make an efficient use of the resources. So we make one particular server to be utilized 100%. So at that time, what do we do? The load on other servers, that is 20, 30, we could transfer to another one that is working on 60, so that we could make it 100%. So like that, we could find the unused devices. At the same time, we could find the devices which are not running. So due to that, we can carry out a lot of consumption of energy. Okay, so with respect to each layer, what we have observed, starting with respect to the hierarchy from the higher to lower, the cloud, okay, edge resources, and the end devices. So each and every level, with respect to these devices, a consumption of energy is going to be carried out. Okay, that should be carried out. Okay, next, financial cost. So as I already mentioned, okay, energy consumption has the implication on the financial cost. So here we have to make a decision that how much of resources do we require, okay, or how much of computation resources, how much of processor, whether we require a high end processor, whether we require a low end processor, okay, whenever we are running an application. So depending on the budget, we could spend on that. Okay, so if there is a prior plan to us that we are going to in future we are going to run with complex applications, at that time itself it would be better for us to move to the higher ends of the resources. That means we could go with a higher end processor. So definitely whenever we are going for a higher end, we could expect to get a higher quality, we could expect to get the results within no time, we could expect to spend certain amount of financial things also there. So that is nothing but related to financial cost. Okay, next. So beside these standard things, we could also consider some other attributes or some other parameters which are affecting the metrics with respect to the working of the edge devices in the fog. So what are they? There are several other ways to address the quality attributes to increase the reliability. Okay, reliability means what? Whether we are running the application, whether the application is reliable to our required thing or not. So unnecessarily we should not run unnecessary applications which are not required as the point of matter. So whenever we are doing a particular task, suppose there could be 4 applications which are required, we should not go for a 5th application, because our limitation, our reliability comes with running the 4 applications. So such kind of things could be found, and we could overcome that. Next, beside security and privacy concerns, so this is also very important. So as whenever we are talking about the IoT devices or number of such kind of routers, whatever it may be, so with respect to wireless and wired devices, they are being connected. So lot of confidential and important data is being transferred through these medias. So at that time, definitely we should concern, security is a major concern. So security and privacy of the content. So definitely whether that is personal data or whatever may be the kind of data, so security must be provided. So perhaps we should measure the level of securities depending on the data. If it is too much personal or too much confidential, so the levels of security could be enhanced. Okay, perhaps a general level of security should be maintained. It is not like that the data is not important and we are not giving any sort of security. Okay, perhaps a 0 level of security, that is the minimum level of security, is required depending on the concept of whether we are going to pass a high confidential information, whatever it may be, through these things. Definitely a high level of security is definitely a major concern. Next, co-location of the computation task belonging to different users. Suppose a user is running an application, so at that time he may require certain devices, though devices may not be within the scenario. So a particular server may be at far away, okay, and a particular storage may be somewhere else in another server that is far away from the present location of the end user. So at that time what happens, it takes a bit of time, okay, so the latency is very high in certain scenarios. So we could reduce them okay, by finding which kind of server is nearby, we could connect to that, so that the response time may be very less. So the co-location is also very important with respect to the resources when an application is run. Okay, next, co-location of the task belonging to the end user. So where the end user is, where the devices are, okay, so the location of these devices and the end users also performs a particular it is also affecting, okay, the metrics with respect to the working of the edge applications. Okay, so these are very important things that we have to consider. Besides that, optimization problems, so whatever may be the task that we have to consider, we have to get a optimal result. Optimal means what? The best. How we could we could get the best by utilizing the minimum things, minimum energy, okay, minimum response time. It is not like that we are getting the best by spending much, okay, it's not like that. Optimization means the best. How we are going to get the best? By making little efforts. Okay, so problem involving with the cloud and edge resources could also be carried out with, okay, so problem involving the edge resources and end devices. If we observe at the hierarchy, so the top level cloud is there, after that edge resources. If there is any problem that is arising between the communication of them, that could be overcome. If after that, the next level, if we observe edge resources are connected to the end devices. So if there is a flaw or any sort of problem between the communication of these two levels of devices, that should also be overcome. Okay, the collaboration is very important, whether the collaboration arises with respect to cloud to the edge resources or with respect to edge resources to the end devices. So that is very important. Next, optimization opportunities along with the service life cycle. So definitely whenever you are designing, that means whenever you are running an application, whenever you are designing an application, so these things should be kept in mind, that is design time optimization. So you have to come up with a design that should give the result within no time. Okay, let it be latency, whatever it may be. We have to develop certain sort of algorithms, certain sort of architectures that could be helpful in order to to get the response within no time. Okay, sometimes what happens, if we observe, suppose consider a heart related patient is there, and through his body a lot of sensors are connected. Okay, so if the sensors are giving correct information, so when a patient is in the critical care okay, ICU, so what do we observe? Minute to minute, second to second information that is given from the sensor devices which are connected to the body is very important, so that the doctor could respond that what is happening, what kind of treatment could be given better, like that. Okay, so deployment time optimization. So deployment time, okay, so this is the problem. This application should be deployed. Okay, we require this kind of task with respect to the application that we are going to run. So definitely deployment time is also important. Deployment time we can compare with a real time scenario. Suppose a person has that means jumped from a high aeroplane, so he is having a parachute. So he should open the parachute within a correct time. Okay, so where should he deploy? When he is about 5 or 3 kilometers away from the land. So the deployment time is very important. It doesn't matter that he is going to open the parachute when he comes to 1 kilometer near the earth, so like that. So deployment time is very important. Next, runtime optimization. So it should take a bit of small runtime to get the results. Okay, one is design is important, deployment time is important, and runtime is important. So these are the optimization things that we could observe in order to enhance the quality of the services that we are getting from the edge resources with respect to the end devices. Okay, so the following characteristics we can observe with respect to optimization. What are they? Adoption of non-linear. Non-linear means what? Even we are not getting the inputs and outputs correct, we could consider them. Okay, next, non-convex optimization techniques, usage of heuristics okay, to drive potential, suboptimal, not only optimal, suboptimal things also we should consider. Usage of the distributed algorithms, as we have said na, to develop a design time, to develop an deployment time. Okay, so we have to rigorously work on a optimized algorithms for that. Okay, so that could give us a better results. So future enhancements that could be done with co-optimization. So not only optimization, when we are running an application, so in that application coordination of devices, coordination of the resources is very important. So it doesn't matter that one resource is working with optimality and another is not working with optimality. If both are good, suppose in a class what do we observe? If everyone gets a placement, then we could say that 100% placement has acquired by the class. It doesn't matter that if out of 60, 10 grabbed high packages, we could not say that 100% placement has achieved. So in the similarly co-optimization, so between the resources which are helpful for running the application, optimization is very important. Next, balancing multiple optimization objectives. So suppose when we talk about a particular devices, each device is having its own balancing or threshold level of the optimization. We could not say that the router is having this one and another kind of server should also have the same value. Okay, we could not compare them. So balancing multiple optimization. Okay, next, that means what, in a group, if you want to take a good decision, what do we observe? We have to convince all of them. Okay, all of them may be of different thoughts. So in the similar way, when you are running an application that requires various devices or the various resources, every resource they are having their optimality at different thresholds. We have to coordinate among them. Okay, next, algorithmic techniques, we have to use best algorithmic techniques in order to achieve all these things. Next, evaluation. So we have created a good algorithm basing on which deployment is running. Okay, time is consuming less. So we have to measure whether we could do best out of this or not. Okay, if that is the best, we could satisfy with that. If that is not best, further we could carry out okay, new things in order to observe what are the best things for that. Okay, so this is the end of the concept. Hope the concept is very clear to you. Thank you very much.